welcome to the structural stormwater control science review and synthesis talk. This is being given by Aimee Navickis-Brasch and Maria Peraki. And feel free throughout this talk to type your questions into the chat box, and we will either get to them at the end or they will be answered after the fact. But Aimee, go ahead and take it away.
Thank you. So my name is Aimee Navickis-Brasch, and I am a stormwater engineering manager at Osborn Consulting, and myself and Maria, who is a researcher on this project and also works at Osborn, will be going through the presentation. We do have other consultant team members that I'll introduce shortly that have been working on the project. I want to acknowledge them for their contributions, and they'll also be available along with Maria and I to answer questions at the end of this presentation. So this presentation is about the Stormwater Structural Control Science Review and Synthesis project that we've been working on. A little bit about what we're going to talk about. I'm going to first give you an overview of the project. This is going to include some of our scope of work and how it relates to current and future permit requirements. And then I'm going to go over the benefit questions that we answered during the study and our approach to answering them, going through how we defined key terms first, our approach to the literature search, how our approach changed based on the available data that's out there. And then I'll provide you with an overview of our responses to the questions. There is another part to this, which is the application questions, and we were putting a presentation together hoping to go through both, and we felt like it was not possible to have it make sense within this time frame, so we pulled the application piece out and we'll focus on the benefit piece and let you know how that fits in with the project as well. And then we'll talk a little bit about the next steps for the project, what's going to happen next, and then we'll end with questions from attendees. So the goal of this project was to develop an objective science-based approach and white paper that'll be used by municipal stormwater permittees to inform the selection of retrofit future projects and provide a basis for stakeholder policy discussions to inform the 2024 NPDES municipal permit for stormwater structural controls. So then we have the project team, which is a lot of people, and it was divided into two groups. We have the TAC, or the Technical Advisory Group, and their role was to inform the project, provide input and feedback throughout the project, and identify priorities and focus areas, question what we're doing, really think about how this information will apply and could be considered for those future policy discussions. They played a really important integral role in providing feedback going through this process. Then we had the consultant team, and that consisted of myself and Maria from Osborn Consulting, as well as Paul Fent from Parametrix, Kristen Nilsson from GeoSyntec, and James Packman from Aspect. Paul and James are also in the speaker room and available to answer questions about the presentation. So the consultant team would meet, we'd go over the plan for how we're going to conduct a literature search or answer questions. We'd go off and do our own literature search, bring our data back together and review it, discuss it. We had some pretty intense philosophical, theoretical questions, challenged each other on how that information can be applied, and worked together to come up with proposed responses to the benefit questions. And we're working through the application questions now. And then we would meet back with the TAC to get their feedback as we're going through the project. It's also important to note that the client for the project is actually the city of Tacoma. And then while they have TAC members on here, we have kind of a unique setup with the project that the consultant team was working more directly with the TAC than the city. So let's talk a little bit about the specific permit requirements. So if you missed Emma's presentation right before this one, I'm going to just hit on a few key points to make sure we're all on the same page with these. So stormwater structural controls. They are, it didn't change, sorry. There we go. Stormwater structural, SSC stands for Stormwater Structural Controls. These are different maintenance activities or structural BMPs that encompass a group of about 11 different category types that fall under that umbrella. The SSC requirements are part of the NPDES MS4 permit requirements, and they stem directly from EPA rules in the CFRs, which suggest that SSCs should be included in stormwater management programs. So the goal or the purpose of the SSC program is it aims to retrofit existing unmanaged, unmanaged or inadequately managed developed areas to reduce impacts to watershed hydrology and pollutant discharges from the MS4 that are not adequately addressed in other parts of the permit. So think about it this way. The permit first was implemented in 1995, and everything developed before that most likely did not meet the stormwater management requirements in the permit. So the SSC requirements are retrofit requirements. It's going back and retrofitting those developed areas that don't have stormwater management or stormwater management is inadequate. Again, those are their permit requirements. They are in the phase 1 permits. They've been there since 1995. And as most permit requirements, they have evolved and expanded within each permit recycle. And we anticipate that in future permits that will continue, and they will expand and evolve and likely include the phase 2 permittees as well. So what are the SSCs exactly? There are 11 different project activity types that fall under this umbrella. These include new flow control facilities such as a detention pond, new runoff treatment facilities such as a biofiltration swale, new LID BMPs like porous pavement, and then retrofitting of existing treatment and or flow control facilities. So retrofitting one of the 1, 2, or 3 items listed there, a flow control facility, a runoff treatment, or an LID BMP. The first 4 SSCs that are listed are all ones that you would find in the Stormwater Management Manual and that has guidance for developing them. The other categories include number 5, property acquisition for water quality under flow control benefits, maintenance with capital construction costs greater than $25,000, restoration of a riparian buffer or forest cover area, some type of flood reconnection projects, as long as it's not to a flow control exempt water body, permanent removal of an impervious surface, and the last category is other. So those are actions to address stormwater runoff into or from the MS4 that are not otherwise required by S5C section in the phase 1 permit, which is controlling runoff from new development, redevelopment, and construction sites. So last slide on the background and overview of this related to the SSC points and multipliers. So in the phase 1 permit, specifically Appendix 12, there are requirements that define specific items related to the SSCs, including the reporting instructions for how permittees are to document the work they've done to meet this requirement and the progress that they're making on meeting these requirements each year. There's also a section that defines the project types for each category. Sorry, wrong screen. There we go. And then it provides some type of definition for each of them that includes a definition as well as eligibility of the different SSC requirements. There's also information about non-qualifying projects, which projects are not going to get you the points you need to meet your permit requirements. Most of these are activities that would occur below the ordinary high water mark. And then there's instructions for calculating points. Specific to the project type, there's a multiplier that's applied, and then some type of measure, such as equivalent area, length, or area is applied. So the table to the right is table 3 from Appendix 12. And this defines first, in the first column, the relevant SSC project type number, and then a description of the achievement for each of the different SSCs that you can get credit for. And then there is also some type of multiplier that's listed in here The multipliers were developed to help with scaling the benefit of each SSC. They're intended to reflect the MS4 retrofit priorities, as well as receiving water condition and project effectiveness. The first 4 pretty much rely on equivalent area as part of determining the number of points based on a multiplier. And those relate again to the BMPs that you're going to find in the Stormwater Management Manual. The equivalent area concept came up because it's similar to what you would use for a water quality grant and how you measure benefits. The other SSCs going down from 5 to 11 look at area, like area acquired for property acquisition, or the length of the work done for some type of maintenance activity. Anyway, so there is a minimum number of points that are required. 300 SSC program points are required by December 31st of 2022. And there's specific guidance for what those points look like. So 225 can be projects that are in the design stage, but a minimum of 75 points have to be projects that are complete or in the maintenance phase of the project. Okay, so thinking about those requirements in this project, how does our project fit in with these particular requirements? I think of our project as sort of a prelude to the project requirements, in that the consultant team worked together to collect data and information that was needed to understand the existing body of work that's been done on SSCs and be able to answer these research questions and help better understand the SSC program. So there are 3 main elements to this project. That is developing responses to benefit questions, developing responses to application questions, and preparing for future policy discussions. The questions that we're addressing related to the benefit and application of the SSCs, these were developed prior to the start of our project. An outcome of our project will be a white paper at the end of this. For developing responses to the benefit questions, just to generally characterize what those questions were, these are a series of questions that are related to the SSC qualifying project activity types. They're stormwater related environmental benefits, meaning the water quality or hydrology benefits, the impact that they're going to have, and metrics for measuring those benefits. So how can those benefits be measured and quantified? Looking at the responses to application questions, these are a series of questions that relate to the permittee selection and application of the SSC qualifying project activity types. So we're taking all the benefit information that we've collected and looking at it to figure out ways that it can be applied and ways to select different SSCs to get the best benefit. With respect to policy discussions, we're working on developing a draft plan and schedule for a future charter workshop that outlines how recommendations from the white paper can be applied to the SSC requirements in the 2024 permits. The primary focus of the white paper that we're developing is going to be used to inform a series of discussions about the minimum SSC level of effort that's going to be required of permittees and the best ways to measure and or assess that level of effort. For this work, there'll also be a new stakeholder group that's formed. We'll have the initial meeting for that at the very end of this project, and then our project ends and that project begins. So just highlighting that for this presentation, almost everything we talk about is going to focus on the process for developing responses to the benefit questions, and then also reviewing what our proposed responses to those questions. Okay, with that, I will turn it over to Maria.
Thank you, Aimee. So before we start talking about the literature search and the responses to the benefit questions, we thought it might be a good idea to give you some definitions of the terms that we're going to be using throughout this presentation. That was actually the first step of our process. We met with the TAC members and we made sure we're all on the same page in regards to the definitions of the terms that we're going to be using. So starting from the contributing basin, the contributing basin encompasses certain impact factors that are the conditions within the basin that may influence the performance of the BMP. Those variables may include land use, soil types, or topography. The contributing basin generates runoff, which is then collected by the SSC BMP. The SSC BMP has associated with it certain performance limitations, and those could be the BMP type, the BMP sizing, filtration rate for LAD BMPs, and the media thickness. And those are just examples of the design parameters that they could influence the stormwater-related benefit of the SSC. Each SSC BMP involves certain mechanisms that they are the flow control or treatment processes that provide the benefit. And those mechanisms can include sedimentation, filtration, absorption, among others. The SSC produces a certain benefit, which then could be split into the stormwater-related benefit, which includes the hydrology benefit or the water quality benefit, or other environmental benefit, which examples are groundwater recharge, air quality improvement. For the benefit, there are certain single or combined variables that can be used to measure the benefit. For this analysis, we're going to be using performance indicators to estimate the stormwater-related benefit of each SSC.
Sorry, I'm one step behind you because I'm looking at the other screen that has the, and I'm looking at next slide, sorry.
That's fine. So the consultant team was asked to provide responses for 7 benefit questions that can be split into 2 main groups. The first group relates to the SSC stormwater environmental benefit, mainly defining it and quantifying it. And the second one relates to the metrics for the stormwater related benefit. And those metrics revolve around the metric applicability under different site conditions or impact factors as we define them, limitations of the metrics, single versus multiple metrics approach, best metric, and a potential approach for comparable benefit through metrics. In order to respond to those questions, the consultant team conducted a literature search, and I'm going to be outlining the approach and findings in the next slides. In order to gather all the data for the performance indicators for each SSC, we created a table just like the one that we're showing here. We're focused on performance indicators for hydrology, water quality, and we split the water quality performance indications into parameters that they're regulated by the NPDES MS4 permit and common TMDL pollutants. For SSCs 1 through 3, a decision was made after coordination with the TAC group to use the ecology approved performance standards, the SWMP standards, and not perform a literature search for those parameters for SSCs 1 through 3. The consulting focused the literature search effort on finding performance indicators for SSCs 1 through 3 for the common TMDL pollutants and for all the parameters for SSCs 4 through 11. So in order to keep the literature search in track, we created a template that all the consultant team members were using to gather the data to make sure the same amount of data is gathered from every team. A planned approach was also outlined so that whatever data we collect are comparable among themselves, but also comparable to what we would get from BAPs in Western Washington. In order to achieve that, we developed 4 criteria. The first criterion is we wanted to give priority to Western Washington studies or studies with similar conditions. The next one was we were trying to identify impact factors and how those would influence the results. So we can achieve transferability of data and results. We were also trying to focus on studies that followed a research protocol similar to TAPE. And lastly, BMPs, we were trying to use BMP comparables to Western Washington BMPs. So I'm going to talk a little bit more about the 2 last criteria in the next slides. In this slide, we have a bar chart from data that we collected from the International Stormwater BMP database. We have the frequency of certain percent reduction ranges. And on the x-axis, we have the influent concentration, which is a very important tape parameter. Here you can see to the far left, we have all the data, and then we have some buckets based on range of influent concentration. With the green box, we're showing the influent concentration for tape of the range that is approved. And then on the left, we have lower influent concentration, and then on the right, we have higher influent concentration. As you can see, as we move from the left to the right, the orange box on the top that shows greater than 80% reduction is getting bigger and bigger, more and more frequent. And we're losing the leaching, which is the blue box, which is instead of reducing the concentration of dissolved zinc, the BMP is actually increasing it. So we can see how including BMPs that have higher influent concentrations could artificially inflate the results that we're getting for the performance indicators. So here is an example for the BMP comparability. This relates mostly to the BMP design itself. We have 3 BMPs that by name are the same type. On the first one, we have a BMP that is ecology approved and a study that was conducted in Western Washington. And for the other 2 BMPs, it's from a study from UNAIDS. You can see that for the Washington, the ecology approved BMP, we have leaching of nitrate. But for the other 2 BMPs, we do have a significant reduction of nitrate. That is mostly because of the change in the media depth. You see the UNH studies had a greater media depth, allowing for more nitrogen cycling to occur, and also the different composition of the media. So this shows that even BMPs that have the same name, they can produce different results. So by focusing to BMPs that they're approved by ecology, that ensures that we're not including many outliers to our data. So the next step was to actually review the research. So the first we conducted some interviews with permittees and ecology, and we also reviewed the phase 1 annual reports in order to focus a literature search to conditions and practices that they're applicable for Western Washington. We reviewed journal articles which contain single studies or synthesis of different studies. We tried to provide priority to peer-reviewed journal articles, but other material was also included. For databases, we used the International Stormwater BMP database and other databases, and we also reviewed government reports and documents. So we discussed the plan approach. The plan approach led to the literature search, and the literature search led us to recognizing what is the actual data availability. So in actuality, we weren't able to find many studies that provided the data that we were looking to collect and follow the plan approach. We had insufficient information to determine if the conditions were similar to Western Washington conditions. Most impact factors were not specified in the studies. Very few studies were conducted following research protocols similar to TAPE, or we were not provided the details to determine if the protocol was followed. And BMP comparability was mostly unknown, especially in the cases of the data that we collected from the databases, because the design parameters were not provided. Because of that, we actually had to use all the data that we could find. We did try to remove some of the potential outliers using criteria such as pollutant rain loads that are not common in stormwater. But again, we had to use more data than we would like with the plan approach because of the insufficient data that we found. So the performance indicators were reported as percent reduction in the matrices that we developed, with the plus sign showing a reduction and a minus sign indicating a leaching. A wide range was reported, so we provided average, minimum, maximum values and sample size. We included other environmental benefits into the table where those found, and data gaps were identified. I'm going to talk a little bit more about the wide range of reported data with some examples. So here we have a detail of that matrix that we developed for SSC3 new LID BMP. You see how we use the SWMP performance standards for hydrology and how we showed as non-applicable the water quality performance indicators for the regulated parameters. For the common TMDL, we use paired data from the International Stormwater BMP database to produce these average, mean, and max values. You see we have an average reduction of -1% indicating leaching, but a mean of -361% and a max of 92%. So we see a very wide range even within the same SSC type. So moving into the next slide, here's a table that shows results and performance indicators for total nitrogen reduction for different BMPs that fall under the SSC categories 1 through 3. If we focus into 2 BMP types that fall under SSC3, that will be the porous pavement and the high rate biofiltration. If you can click, Aimee. Thank you. You see for the porous pavement, we got an average reduction of -150%. So severe leaching, and for high rate biofiltration, we got an average of 34%. So we actually had reduction. These are 2 BMPs falling under the SSC3 type of projects, and we see how what's the wide range of results that we're getting. So that has contributed to having a very wide range of results and reduction for each SSC type, especially the ones under 2 and 3. Another interesting example was that of the SSC5 property acquisition. We actually were not able to locate any research on stormwater-related benefits for land protected for development. So we switched our approach to show a prevented impact on the environment based on switching from a land that is protected to a land that is developed either for commercial, industrial, residential land use. We use monitoring data for open space since we weren't able to locate runoff data for forest land. So basically what these percentages are showing are prevented impacts and not percent reduction. So for example, if we were to change the land use from open space to commercial, we would expect to see an average of 34% increase in TSS. The same approach was followed for SSC 10 as well, which is removal of impervious area. In order to showcase the data that we found and the data gaps that were identified, we're going to use this table. It's similar to the one that I showed you at the beginning. Instead of filling it out with percentages, we decided to go with a color scheme that is going to make it easy for you to follow the data availability and the data gaps. We're going to start by highlighting the cells for the SSCs and performance indicators that we have as non-applicable. For example, the new flow control facility is not applicable to have a performance indicator for the NPDES water quality parameters because it's not approved to provide that benefit. And we're also showing the SWMP standards that we used, for example, for the new LID BMPs, we use the SWMP standard for hydrology. Next, we move on to show performance indicators that they were calculating using sample sizes greater than 10, and in most cases greater than 100. That was the case for the data that we collected from the international database, BMP database, where we were at the range of above 1,000 in some of the cases, and that is mostly for SSCs 1 through 3 and the common TMDL parameters. Moving on, next, we have sample sizes less than 10. So we found some studies that had sufficient data, but still if there is potential to improve on those results because the sample size was so small. Moving on next, we have, we've located no studies for those SSC types, but we use substitute data, as I mentioned before, for property acquisition and for removal of impervious surface. The restoration of forest cover was a similar case. We didn't find any actual studies for that, but there are some ways where you can approximate the benefit based on the amount of trees that you're planting. And lastly, the data gaps. These were SSCs for which we were not able to find any information to quantify the benefit or even approximate it. Just to sum up, the main issue with the literature search was that, one, a lot of the research out there is not set up to answer the questions that we were asked to answer. And two, in some cases, the detail, maybe the research was set up in a way that will help us, but the details were not reported in the documents that we reviewed. So now Aimee is gonna walk you through how we used all this data to answer the benefit questions.
Thank you, Maria. So I'm going to actually go through the benefit questions now. In some cases, I'll provide you abbreviated responses. In some cases, I'll hit the high points of what it encompassed and give you some examples. Going through all of it would be not very much fun in every detail. So we'll see, hopefully I hit the high points for you. So we start with the first benefit question, which is, what is the most useful definition of the stormwater related environmental benefits or impacts of each eligible SSC project activity type? So for each of the SSCs, all 11 of them, we developed a response to this. We've broken into these categories. We first have a definition of what the SSC is. We collected that information from the NPDES MS4 permit in Appendix 12 and also from parts of the SWMP manual where it's applicable. Then we also define the eligibility characteristics, which are defined from the permit in Appendix 12. Next, we provide the SSC treatment and flow control mechanisms. So that's how the SSC is providing those benefits. We define all of the mechanisms that could exist within each category. And last, we define the SSC performance limitations. And so that's the limitations of the SSC itself. If you change something about that SSC, that can actually influence the benefit you get from it. So let's walk through an example of how we answered the question. We'll just do one example. So this is for SSC2, which is new runoff treatment facilities. So the first part of the definition is just the definition. So that is, we define what it is. They are facilities that remove pollutants from stormwater runoff using the treatment processes noted below. That's the mechanisms noted below. Then we define the SSC eligibility. So facilities in this category do not have to meet the runoff treatment requirements, but they shall be new facilities that provide a treatment benefit for existing development. If the design criteria from the SWMP or equivalent manual is not followed, ecology may request additional project details to support calculations for equivalent area, water quality benefits, and SSC program points. Maintenance activities are not classified under this particular project type. So one thing you notice about the eligibility is there's some flexibility with meeting these retrofit requirements in dealing with the statement about they do not have to meet the runoff treatment requirements. They don't have to hit that same standard. So you do have flexibility with these requirements. So next we defined the flow control and treatment mechanisms that each provide. Even though SSC2 is a new runoff treatment facility and the primary benefit it provides is runoff treatment, we did define some of the flow control mechanisms because just about every SSC is going to provide some type of benefit for flow control, even if it's fairly small. So how those would be provided for this type would be through detention or evaporation, plant transpiration, infiltration, if there was a control structure. But the primary function of SSC2 for new runoff treatment facilities and where you currently get points for these is treatment. And some of those treatment mechanisms include gravitational settling, centrifugal separation, filtration, biological uptake, media or soil absorption, solar radiation, heat conduction. So these are all processes that occur when they occur, it reduces a specific pollutant. It's also important to note that not all of the SSCs have the same treatment or flow control mechanisms. They all have different benefits that they provide. So the last item that we defined is the SSC performance limitations. So that is within the SSC itself. If I change something about the SSC, maybe the BMP type like Maria was showing you, she was showing you that under category 3, there's different types of SSCs that may occur there. It could be bioretention, it could be porous pavement, but they're going to provide some type of different benefits. So the type is going to change it. The design criteria that's followed. If you're following Washington design criteria, you're going to have different benefits than some of the other studies we looked at, looking at the benefit of those SSCs because we couldn't find enough of the data in Washington state studies. The amount of vegetation cover or density. So when we're talking about riparian restoration or restoration of forest cover, the cover type of vegetation as well as the density will have an impact on the treatment benefit or flow control benefit. And the nutrient content of the treatment media. We know in Washington state that the 60-40 bioretentions, for example, can leach. And so that nutrient content can affect the benefit of BMP. No, okay. So the next question that we were answering relates to how does each SSC project activity type address stormwater impacts not otherwise adequately controlled by other areas of the permit, including disturbances to watershed hydrology and discharges of pollutants in areas of existing development, including roads, and prevention of future impacts in areas of new development. So with this particular one, the first thing that's important to note is that the data that we reviewed does not cover all possible conditions for us to assess how each one of these may be addressing stormwater impacts that are not in the permit itself. So to answer the question, we identified what we did find going through the literature itself. The first one, starting with, is just addressing the SSC requirements, which is retrofit. Retrofit requirements are newer as far as having specific amount of retrofit that needs to be done, and they are addressing impacts from existing development where currently it's not managed or it's inadequately managed. Within the data that we reviewed, what we found is that the SSCs can provide additional benefits beyond what's required by regulated pollutants, being TSS, dissolved metals, copper, zinc, total phosphorus, or total petroleum hydrocarbons. There's additional benefits beyond those and additional flow control benefits when it's not necessarily required. And then there's the cumulative benefits of some of the preventive actions that may occur with these. So when we went through all of the data and we collected information, one of the things that we used to define this is, for example, we collected water quality data for the TMDL parameters, and we used that to support this answer and show where we're seeing additional flow or additional treatment that may not be required depending on where it's placed. Also, other environmental benefits, which Maria mentioned, for example, groundwater recharge. So for each of the SSCs, when we could find it within the literature that we were looking through, we also documented those other environmental benefits that are beyond the permit. So the next question asks, what is the best metric for measuring, reporting the stormwater related environmental benefits of each SSC project activity type? So before we go through this response, it's important to define metrics again. So Maria mentioned it before. A metric is a single or compound variable that's used to measure the SSC project activity benefits. And it can provide a method for actually comparing benefits between SSCs. So if you have the same metric with them, you could use the two to compare which one might provide more benefit in a particular location. So in order to answer this response, we collected information from the literature about the different types of metrics that are used, and also asked permittees what type of metrics they have used or would like to use to develop a list. And through that collection, we found that there's 5 different categories of metrics primarily, and that most SSCs can fit within each of these different metrics. So for example, there is percent reduction, and percent reduction is a reduction in flow or pollutant concentrations. So For pollutant reduction, that's a difference between the influent and effluent concentrations. And for flow reduction, it's comparing the pre and post-developed flow rates. Then we have metrics that look at area or length, like the total area managed or improved or acquired. So depending on the SSC type, this could apply to the total area managed by the SSC itself. So looking at what is that basin area and what's been improved for that one. We're talking about volume. This category refers to the total volume that is detained, gained, reconnected, stored, or removed, potentially through infiltration. And then we have cost. This is cost per equivalent impervious area, area treated, or level of operation and maintenance cost. A unique aspect of this particular metric is that it isn't measuring benefit, it's really measuring cost. So if you're thinking of your retrofit program as a whole, and then you're ultimately wanting to get to a point where everything's retrofitted, it's looking more at the cost that you're going through in the process, but not measuring that particular benefit that is being provided. And last, we have mass, and mass focuses primarily on water quality benefits, such as the mass of the pollutant that's removed per year, or pollutant mass prevented from discharging to receiving waters. And so it's calculated by the difference in the BMP influent and effluent concentrations times the estimated volume of runoff that would discharge there. So when we're thinking about prevented from discharging, we're thinking about maybe an area where it's been acquired and protected from development. Instead of being developed, there's going to be a reduction in what could have been released if it would have been developed to, let's say, a commercial area. So as we were going through the literature search, it's important to note that we didn't find a single study that compared the best metric or identified the best metric for any of the categories we were looking at. We did find some studies that just identified what they were, and we do go through some case study comparisons in the last question. But even if we were able to actually find studies that define and identified the best metric, it would be difficult because identifying that greatest benefit is going to vary depending on the specific basin conditions, those impact factors, your receiving water condition needs, and those are going to be unique to each project. So defining best without the context of a project is very difficult. For example, if we're looking at that, if you've got a receiving water body that's got a water quality impairment, and we decide to use flow control as the metric that we're comparing everything by, their percent flow reduction, it's not going to describe the greatest benefit that we're getting from that SSC because it's not focused on that unique benefit we need from it. Sorry, I lost my thought there. Okay, anyway, so, but the best metric we recommend after reviewing all of the literature itself is that it really needs to consider those unique project conditions. It needs to consider the impact factors, those contributing basin area conditions that can impact the performance of the SCC and how it impacts that. And thinking about water quality impairment and what are the needs of the receiving water conditions, and trying to match up those conditions to find the best SSC for that particular project. And a metric that will best represent the benefits that are provided for that. So next, how do land use, receiving water types, and conditions factor into quantifying the stormwater related environmental benefits? So this was the first question we were actually able to answer after the literature search, after we'd reviewed all of the available information and compiled it all together. This one was an easy one to answer. In order to answer how these conditions can impact the stormwater related benefit, we would have had to have found literature that identified those impact factors within the study. So provided information about, you know, the land use in the study or other conditions that are occurring to help us really understand how it could be impacting the two. And also you really need a side-by-side comparison of that type of a study to understand how changing one of those variables can impact the performance. And we just did not find very many studies that identify all those conditions or provided that side-by-side comparison to help us really understand what's out there. What the research does tell us though is that these impact factors such as pollutant sources, land use, infiltration potential, topography and land cover, climate conditions, all of those conditions combined can have an impact on the SSC benefits related to stormwater. So with that, we can't quantify the influence, but what we can do is take the information that's in the literature and develop more of a qualitative influence on how those conditions can impact an SSC. So this is a quick summary of this qualitative assessment. On the top, what I have is impact factor in the first column. These are just different contributing basin conditions that can influence the SSC performance. Next, we talk about how that impact factor can influence the stormwater characteristics. And then last, the potential influence on the SSC stormwater related benefits. So for example, land use. Land use can impact the pollutant types and loadings, and pollutant sources. Pollutant sources can influence the pollutant type, the concentration, and the particular loading that you might see in a watershed. So how does that influence the SSC benefits? Well, influent characteristics can influence which treatment mechanisms you need in order to actually reduce a pollutant. So that's going to be an important factor. And since all the SSCs have different treatment mechanisms, and within the SSCs, sometimes there's different BMPs that have different treatment mechanisms, and some of those are more effective for reducing a particular pollutant. Some are not effective at all, and some have a different life cycle for reaching capacity, meaning for dissolved metals, there's a certain life cycle for the point at which it reaches capacity and no longer provides a benefit. So all of these these are all factors that can impact the SSC performance. So infiltration potential is also an impact factor, and it influences the quantity of stormwater runoff. And how it influences the benefit of the SSC is if you have high infiltration rates, you're going to have a higher SSC hydrology benefit because you're going to have less runoff flow rate and volume through infiltration. And the last two are topography land cover, which can influence the stormwater runoff flow rate. If you've got impervious area and steep topography, you're going to have a faster runoff rate compared to flat topography with grass land cover. Climate conditions can also influence it. Your rainfall intensity, duration, and depth, for example, that can influence the volume and flow rate off of your basin area. And also the runoff energy. That's the runoff energy that's available to actually transport pollutants to your SSC. And so how that'll influence the SSC? Well, the SSC type, placement, and design influences the ability to reduce the basin flow rates and pollutants depending on where it's located. Okay, I think there's two more. So then what are the limitations of metrics across the gradient of urbanization and receiving water conditions? So we're talking about the gradient of urbanization. We're talking about all of those different conditions, those impact factors that can affect the performance of an SSC, such as the percent impervious area, land use, soil type, land cover, all of those things. And some of the ones we were just going through on the last particular slide. So many of these conditions can influence the performance. Specifically, we're talking pollutant reduction and flow control. It is an example. There was insufficient information that was available in the research that we looked at that represents that gradient of urbanization and receiving water conditions. Sometimes it didn't provide enough information about the receiving water at all, or the receiving water conditions were provided. It provided the measure in the receiving water itself, not at the discharge point of an SSC, for an example. So it was difficult to compare the information there. But it was difficult with the information available to figure out what that gradient of urbanization is, and to really understand and determine the influence of that on the SSC performance indicators, and also to quantify the benefit between the different SSC types. So the next question is there a single metric that would make it possible to compare stormwater related environmental benefits across categories of project types? So we're talking about metrics. Again, examples of that could be percent pollutant reduction or flow rate reduction, acres restored, volume removed or detained, cost per area, pounds removed per year. Those are all examples of a metric. So it's asking, is there a single one of those that you could use? And based on the literature that we reviewed, it appears that there's not a single metric that could be used to measure the benefits across all SSC project types. It's just insufficient information to look at all the different contexts for which they can be applied. And because there's just so many different conditions that affect it as well. But also what happens is if you start to combine them and create one, you start generalizing the benefits. So if we're looking at, again, that percent pollutant reduction, and we've got a BMP that really provides more flow control, it's not really going to be measuring that benefit, the primary benefit that we're getting from the SSC if we try to combine it into a single metric. And we just start losing, that single metric would lose the unique and specific unique benefits of each SSC if you do that. Okay, so this is the last question. So then the last question relates to what other approaches might there be to compare benefits of various project types? So we conducted a literature search to find documented case studies throughout the nation of how other permittees are managing their retrofit programs and measuring performance to look at what are the other options that we could have. What we found first is there's no studies that actually compare effectiveness of metrics. They recommend different metrics or describe the metrics they use, but there are no studies that compare which one's the best metric. And in the case studies reviewed, what we were able to group the information into 4 categories. One is the most common water quality metrics. So pollutant reduction is the most common water quality metric that's used to measure the benefit of a type of retrofit program in different places in the nation, which is the same as what Washington does most of the time too. Common hydrology metrics that are used are percent flow or volume reduction seems to be the most common one. Again, that's similar to what we're doing in Washington as well right now. Then we also looked at common LID metrics. There were a lot of questions that came up from the TAC about how the current metrics in the SSC program and the points, they're not measuring all of the benefits that LID can provide, such as groundwater recharge as an example, or creating a hydrological connection from groundwater back to receiving water. So those are not quantified really in the current system. So what we found in the research is other places in the nation are looking more at targets or monitoring before and after. So a target would be the permit requires them to install 5 LID BMPs each permit cycle. That's the example of some of the targets we found. The other is monitoring before and after. So monitoring your discharge into a receiving water, putting in the LID BMP, and then monitoring after that and comparing the two to see how the LIDs benefiting the receiving water. So I would say a big gap that I noticed in the literature was that they weren't good definition of metrics related to LID and how it measures benefits. And then the concept of a shared metric. That was the other one that we saw pop up. And it's a shift from thinking about the permit as a discharge point to shifting to the watershed base. So looking at the watershed as a whole and all the permittees that are discharging and developing a plan to benefit those receiving water conditions. And some of the shared benefits were actually trading credits. So if one jurisdiction did more than they needed, then in a particular area and somebody else did something else, actually having a trading program or selling credits to other permittees was another example. Okay. So that's the answers that we got for our benefit questions. Our next step, we're finishing our application questions now. And that is how our responses are leading to applying the information we found related to the SSC program and selecting different SSCs. We're also working on a white paper that will be finished up in the next couple months. And then we're shifting in at the very end of the project is the beginning of the policy discussions and developing the charter for that. So And that is the end. Our contact information for Maria and I is here, and we are open to answering your questions. I think we've got 11 minutes for questions.
Yeah, I will go ahead and start. We've got a couple in the chat here. The first one is asking, is mature tree retention in urban environments discussed relative to restoration of forest cover?
Paul, you want to take it?
Yes, it was included in the literature search and so on, and there weren't a lot of, there was actually a really fairly good paper that summarized all the work that had been done, and most of it just translated into metrics that could be used or applied. And so we're kind of taking that in that direction as far as what's the value of those trees based on the research that was done on the trees and so on. So it is in there, and it's being considered because it's one of those places where we did find data. So
good, thank you. The next question, under the benefit question 2A, are there other metrics that could be considered, such as velocity, shear stress within downstream natural waterways, temperature, DO, wildlife or fish count, species, etc.?
So there's definitely other metrics that could be used. First, I don't think we clarified this in our presentation, but we defined where the measurement of the benefit occurs, and that's occurring at the discharge point of the SSC and not in the actual receiving water conditions. And that's related to the permit definition. So it's everything really above that ordinary high water mark. So there's definitely other ways that we can measure it. What we identified in the literatures was what was more common metrics that are being used, and also thinking about simplicity with some of them as well.
Awesome, thank you. Could the team, or would the team be able to convert area or length to mass of pollutant removed or prevented from discharging, or volume?
Trying to find that one in the chat box.
Oh, it was a message. And so, you know, with all of these, it was a direct message, I think, just to the host. Yeah, some of these are just, they're a combination of to everyone and just to.
Oh, okay, can you read it one more time? I'm sorry.
Yeah. Can the team convert area/length to mass of pollutant removed or prevented from discharging, or volume?
Well, you could. I think that wasn't the focus of what we were doing, though. Our focus was really to answer specific questions that were developed prior to the consultant team being hired, and identify what they were and come up with whether or not we could find a best or a single metric that could be used, and the benefits, the pros and cons of that.
Yeah, and this is kind of a follow-up to that, but do you think that there is a better, or better single metric for pollutant removal, i.e. Pounds removed per year, etc.?
Gosh, so that's like a debate within the consultant team itself. So that's kind of been the fun part of working with the consultant team and doing that. And so I started with percent pollutant removal because that's what we currently have in the stormwater manual and what I feel everybody's most familiar with. But there are definitely other ways, and I'll let Paul and James pipe in here too, but other ways, looking at like measuring just the effluent concentration as a measure and trying to be below a target or a benchmark for that. There were other ones. Looking at cost was another one. So Paul or James, do you want to also provide your input on that?
Yeah, this is Paul. So I guess I just quickly say that we want to make sure that you don't get credit for dumb luck, meaning like you happen to be worse and you get more to remove and so on. That we want to make sure that there's some consideration of the effluent and that what the actual outcome as the result is, because that directly translates into benefit.
James, did you want to pipe in at all?
Yeah, I would just add to that that we did start to address that type of question, or that question, in the application questions, which Aimee mentioned we're currently in process with. And I would say that briefly, it partly depends on what the SSC is in terms of something like the most relevant benefit metric. And we talked about things like effluent concentration, as others have mentioned, but also cost was a metric, while not a scientific process metric. It's a common metric that applies to every SSC. And so we're trying to tease out how we could use cost as a way to simplify what the benefit, how the benefit could be quantified.
Thank you. We're getting a lot of questions, so we probably won't be able to answer them all here today, but we can have the team answer them after the fact. But I'll just keep going down the list. Despite the complex nature of watersheds, what does the team recommend to simplify and focus on the most relevant benefit metrics and performance measures for a program that is achievable and implementable for permittees in this present point in time?
I think we kind of answered that in the last one. I think with relating to cost, relating to the metrics that are actually in the permit now are simple. But I think the ultimate one is that we feel that every project and project site and basin area have so many unique things that are going on that some of that should be left up to the permittee to figure out what the best approach is for quantifying their benefit.
Awesome, thank you. Where in the country is most of this research being performed? Is there a region or biome focus in research studies?
Gosh, so for the, it depends on the SSC itself. In actual category 11, which is other, and that primarily focused on street sweeping and line cleaning. To be honest, the best research I found for some of that was in Washington, and Tacoma had done some amazing work. And so we found some really good information there. Some studies, like the SSC 1 through 3, 4, which are the ones that you'd primarily find in the stormwater manuals. There were some things that we found in Washington State, but really not enough to go through and look at. So we ended up going to the International BMP database, and I didn't look at all of the studies. I know there's a lot of work being done in Minnesota, Chesapeake Bay, California, Texas, North Carolina. So different areas that we see it. And then for some of the SSCs, like restoration of riparian cover and forest cover, some of those are relating directly to stream work. You see some of that in the Pacific Northwest, but there's not a lot of it. So there's some limits there.
Yeah, absolutely. Was climate modeling included in the impact factors within your study?
Climate modeling?
Yes.
Climate was included in there, but we didn't get into modeling with it.
Gotcha. And this is a question of, can you point the audience towards research or literature that speaks to groundwater recharge and hydrologic connectivity as it relates to LID projects, specifically not being a known or quantified metric of LID projects, as you mentioned?
Aimee, I can jump in and just start the response to this one. Yeah, this is James. So suffice to say, we did not look at literature that was specifically focused on groundwater recharge. I think when it comes to groundwater recharge, myself as a hydrologist, I think about that as slightly deeper water bodies, aquifers, and the infiltration from LID is usually more shallow and doesn't reach aquifers in the same way that something like UIC would. Which I see that there's a presentation on that later today.
Yeah. Well, that is, go ahead.
Yeah, it's
got like 30 seconds. So.
Building on what James said, it's important to note what we focused on for stormwater related benefits was water quality and hydrology, and that the groundwater recharge would be an other category benefit. So it wasn't the focus on that one.
Gotcha. Well, thank you again, everyone, so much for that presentation. We've got a lot of good conversation out of it. And we will go ahead and conclude the session.